Welcome to this explainer. If you've ever tried to picture an atom in your mind, you were probably told that it's actually just this fuzzy, unpredictable cloud of probabilities. Well, today we are going to explore an entirely different perspective. We're looking at Dr. Ahmad Rihan's fascinating geometric hypothesis for atomic structure. We're going to take you on a literal architectural tour of the atom, looking at a framework known as the resonant atomic matrix, or simply the RAM model.
So, what if the atom had a hidden, precise geometry? Let's dive into this simple but absolutely profound question. It completely challenges how we visualize the very building blocks of our universe. For nearly a century, we've relied on abstract math to describe atoms. But this hypothesis asks, what if there's an actual, explicit, physical structure down there? What if the atom is less like a cloud of chance and more like a precisely engineered machine?
To guide our journey right to the center of the atom, we'll follow this 6-step blueprint. First, a new blueprint, then the 4 surfaces, sorting particles, the core's Higgs pyramids, filaments and knots, and finally, predictions and tests. All right, kicking things off with part 1, a new blueprint. The RAM hypothesis offers a physical, concrete architecture as an alternative to the invisible probability clouds we're so used to in standard quantum mechanics. Now, standard quantum field theory is incredibly successful, sure, but it partitions elementary excitations in a highly abstract way. The RAM model doesn't just throw those rules away. Instead, it takes them and embeds them inside an explicit, tangible nuclear geometry. It basically gives the math a physical house to live in. Moving right along to section 2, the 4 Gaussian surfaces. So, according to the hypothesis, the atom is organized by 4 nested boundaries called Gaussian surfaces. And these aren't just imaginary lines drawn on a chalkboard. They're specific non-Maxwellian vacuum fields. Essentially, they are highly specialized zones of empty space where all the atomic action happens. They act as the absolute borders that separate the nuclear activity on the inside from the electronic activity on the outside, completely regulating how particles behave and interact. Imagine it like this. These 4 geometric surfaces cross each other perfectly. You've got a protonic and electronic surface sharing one plane facing opposite directions. Then, rotated exactly 90 degrees, you have the neutronic and antineutronic surfaces. This orientation is fixed by a strict resonance indition that keeps their fluxes entirely orthogonal or perpendicular to one another as the nucleus rotates. In this model, these very surfaces enforce the rules of physics, making sure particles exchange phases correctly just by virtue of their geometry. Okay, on to part 3, sorting particles by geometry. Instead of just floating randomly in some void, particles in the RAM model are strictly sorted based on their quantum nature. Fermions, which are the particles that make up matter, like protons, neutrons, and electrons, are strictly confined to those specific outer surfaces we just talked about. Meanwhile, bosons, the force carriers like photons and gluons, they're allowed to occupy the geometric cores or travel along the exact intersections where those surfaces meet. It's a perfectly organized system where a particle's physical location is dictated entirely by its fundamental properties. Now for my absolute favorite part, section 4, the core, specifically Higgs pyramids. We usually picture the nucleus as a bunch of clumped-up spheres, right? Well, not here. In this model, the core is made of central pyramidal bodies. These discrete pyramid-shaped units are interpreted as literal quanta of the Higgs field. They sit right in the center, acting as immense energy reservoirs. And they aren't static at all. They execute continuous vertical oscillations about the nuclear midplane. This precise thrumming motion is what actually generates the atom's fundamental periodicity. And here is where it gets really wild. In this geometric hypothesis, the collective number of these Higgs pyramids exactly equals Z, the atomic number. Think about that for a second. The atomic number isn't just a basic count of protons anymore. It directly corresponds to the number of discrete pyramidal energy units sitting right there in the core. It links mass and energy storage directly to a physical geometric shape. And because they're bosons, all these pyramids can seamlessly share the same central space, storing energy until it's ready to be liberated. Let's look at the internal wiring in section 5, filaments and topological knots. You're probably wondering, how does this whole thing not just fly apart? The RAM hypothesis proposes a dense network of space-time null filaments that freely penetrate both the surfaces and the core. Think of these light-like filaments as ultra-strong invisible tension wires. At every intersection, there are interlacing topological knots of integer charge. These knots literally lock color flux into tight tubes, providing the exact tension required to confine quarks together. It's a phenomenon known as color confinement, beautifully explained here through literal geometric tension. Let's put this into action. This internal wiring builds an incredibly dynamic picture of how atomic energy is released. When the atom experiences a strong collision, it doesn't just bump away like a billiard ball. Instead, one of those internal tension wires, a null filament, experiences a sudden snap. When it snaps, all that stored color energy cascades out along the intersections of the surfaces, appearing to us as a coherent photon thread. Energy release is literally the snapping of atomic tension wires. How cool is that? Finally, bringing it to reality with Section 6, Predictions and Future Tests. So one of the fascinating, testable aspects of the RAM model is how it predicts that geometry actually scales with size. For light nuclei, the model approximates those four surfaces as simple concentric spheres. But as you add mass and move up to medium and heavy nuclei, the arrangement of all those Higgs pyramids forces the geometry to shift into complex tetrahedral or pyramidal shapes. This structural shift inherently changes the eigenvalues, meaning the literal oscillation frequencies of the atom itself change based on its shape. Because of these geometric properties, the model impartially lays out three very concrete qualitative predictions. First up, high-resolution collision spectra should show a primary elastic peak accompanied by equally spaced satellite peaks, which are basically echoes of the core's higher oscillation modes. Second, there should be systematic shifts in frequency between isotopes simply because adding neutrons changes the physical stiffness of that neutronic surface. And third, as I just discussed, there should be a direct, observable correspondence between the snapping of filaments and the emission of photon thread cascades. These are actual things that can be looked for in a lab right now. As the source paper beautifully sums up, whether this specific hypothesis ultimately proves entirely correct, or if it needs revision down the line, it does something vital. It supplies a concrete, visually explicit alternative to purely abstract equations. The RAM model provides a structurally unified way to think about mass, energy, the origins of the atomic number, and the mechanics of color confinement, all of it emerging from one single set of surfaces and filaments. It kind of makes you rethink high school chemistry, right? By giving the atom a dedicated architecture, we might just uncover the actual mechanical secrets of the universe. I really hope this explainer sparked your curiosity and gave you a whole new way to visualize the microscopic world. So what do you think? Does the future of physics look less like a random cloud and more like an engineered blueprint? Thank you so much for joining me on this incredible architectural tour of the atom. Keep asking questions and keep learning.